Astronomical telescope. These are an optical instrument which we use to see distant objects, heavenly objects like galaxies, planets, stars, and many other such things, many other such heavenly cosmic phenomena also. So, astronomical telescopes can be of two kinds, reflecting type and refracting type. We are now learning the refracting type telescope, particularly Galilean type telescope. In refracting type telescope, we have two lenses. It is again an application of combination of lenses. In this case also we have two lenses, just like compound microscope. We have a objective and we have a eyepiece. The lens which acts as the objective, its function is to collect light from very distant stars, very far away objects. So, its focal length is very long, unlike the objective of compound microscope where the focal length is short, as the light is to come from microscopic object. But in case of telescope, the objective's focal length is very long. More long is the focal length, more distant objects we can see. On the other hand, the eyepiece, the function of the eyepiece is to magnify the intermediate image and produce an enlarged detailed image. Okay. So, the focal length of the eyepiece is preferably as small as possible. More small is it, more the magnification is. Okay. So, now we will find out the magnification for the near point adjustment of an astronomical telescope, refracting type astronomical telescope. Let us see how to do it. You see, we have two convex lenses. Now, in case of refracting type telescope, in case of telescope, the rays comes from very distant objects. So, as a result, they do not form, all the rays do not pass through the focus. So, as a result, the final image is formed at the focal plane, not at the focus. So, this is one of the very important point to note in case of astronomical telescope. So, consider one such ray, consider some rays coming from very far at certain angle alpha. This is one ray, this is the another one, which after refraction they do not pass through the focus, rather forms an image at the focus. So, this is the image at the focus. Okay. Focal. So, they form an image at the focal plane. Now, these image act as an object for the eyepiece. So, again two rays, we are going to consider two rays. Definitely one will follow from here, and after refraction will pass through the focus, and another ray will go through here, to the optical center, and that goes through the focus. The end result is that if I extend these two rays, we find an image somewhere here. We found our final image, which is magnified, to the, so this is the intermediate image, okay. So, and these are the rays, okay. This is the focus of the eyepiece. Now, so So that means the object is formed at the image by the objective is formed at the focal point of the objective. So this point is f of o. This point is f of o. Now, in order to see it to be magnified, as usual, this should be inside the lens, should be this intermediate image must be in between f of e and optical center of the eyepiece, right. So this is A, B, this is A prime, B prime. This angle is alpha. If this angle is alpha, definitely this angle is also alpha. This angle is also alpha. Okay, let me use the red color to explain this to you. So this is also alpha, right. So now this point is, let's say this is also the optical center O, and this is optical center of the objective. This O dash is the optical center of the eyepiece. So now where is beta? Beta would be definitely this angle will be beta. This must be beta. So then angular magnification will be m will be equal to tan beta by tan of alpha. So what is tan beta? Tan beta would be AB by, how much is this distance? This distance is UE. So it is UE. What is tan alpha? Alpha would be from here to here. This is VO, but VO is nothing but actually tan of alpha would be AB by the VO, but VO is nothing but, so you can see I can cancel AB and AB here. So we get here VO by UE. But what did we say? That the object is formed at the image formed by the objective is at the focal point or at the focal plane. You have to remember that. So that means VO is nothing but f of o, and UE must be negative, UE using sign convention. So we get our magnification to be, so our m is equals to nothing but minus f of o by UE. Now this relation is fine, we can use this expression to find the magnification, but this one do not, as we are finding out the magnification in case of least distance of distinct vision. That means the final image is formed at D, 25 centimeter from the eyepiece. So this is not present in this expression. So we have to manipulate it little bit. So how to do it? So you see, we know U equals to minus UE, V would be minus D. So using this on this relation, 1 by f of e is equals to 1 by V minus 1 by UE. We can write this as 1 by minus D plus 1 by UE. So 1 by UE is equal to 1 by f of e plus 1 by D. Now 1 by UE, if I multiply this relation f of e by f of e, I get here 1 by f of e plus 1 by D. So if I multiply it, I should get here 1 by f of e and then 1 plus f of e by D. Therefore, substituting 1 by UE in this equation, equation 1, substituting in 1, I get m is equal to minus f of o by f of e 1 plus f of e by D. So this is the magnification of the astronomical telescope in near point adjustment. Okay. magnification at far point adjustment, also known as normal adjustment. Okay, also known as what? Normal adjustment for astronomical telescope. So now let us draw the principal axis. This is a principal axis. Imagine this is the ray which is coming from a very far away object. Okay, which is making certain angle alpha to the, they form alpha to the telescope. They form the intermediate image. They form the intermediate image. Okay, let me make this little big so that your last time my diagram was little congested, so I will try to make it little big this time so that you can get the picture the same thing only. So this is the object. Okay, the intermediate object. Now this is the image produced by the objective. Now this image will act as an object for the eyepiece. So again we consider two more rays, one being parallel to the principal focus, after diffraction pass through the focus, and another goes through it, goes through the optical center. These two rays will meet at infinity. Okay, so the final image is now formed at infinity. So these are the arrows giving the sense of the direction of light. In all ray diagram, don't forget to give the arrows, because it's in ray diagram arrows plays a very important role, and you know we always consider the diffraction from the center. This is just for drawing purpose. Now this is A, this is B, this angle is alpha. If this is alpha means this one is also alpha, and this is beta. Okay, this is at infinity. Now we need to, and here is object is somewhere at a very far away distance, AB. So to find the magnification in normal adjustment, we can simply consider, we know the angular magnification m will be tan beta by tan of alpha. Now what do you think tan beta would be? Okay, let us name this as A prime, B prime. So A prime, B prime by, how much is this distance? This distance is, okay, so remember now the main condition for the this object, for the final image to be formed at infinity, A prime, B prime must be at the focal length of the eyepiece. Remember, because when an object is placed at the focal length of the convex lens, the image is formed at infinity. Same concept here. And so this distance is from here to here, this is f of o, and from here to here it is f of e, because in case of telescope the image formed by the objective is at the focal plane. The image is formed at the focal plane, not at the focus. So this is the f of o, correct. So we can write tan beta would be A prime B prime by A prime B prime by base. So base here would be f of e, so minus f of e. And what is alpha? A b by A prime B prime by alpha would be f of o. So this gives us magnification to be minus f of o by f of e, and that's it. So magnification of the astronomical telescope in normal adjustment or in far point adjustment is minus f of o by f of e. That's it. Now, one thing you should note when learning compound microscope and when learning the astronomical telescope, the normal adjustment in case of astronomical telescope is more important, and in case of compound microscope, image formed at in near point adjustment is more important. Okay, because you see generally you will be using telescope to see distant object, and in case of compound microscope you will be we will be using it to use it to see close objects. Hence, these two elements are important for these two optical instruments. Okay, so that's it. I hope you have liked it. Thank you.